So we should all be happy here that we move up by a constant each time. This is a constant difference, isn't it? Okay, and this is arithmetic. Now, we've seen these in the IGCSE. Now, this one, what we're actually doing is each time we're moving by what we call a ratio or a scale factor. Okay? And this type of sequence is known as a geometric. So arithmetic is if we're adding or taking away each time. Geometric is if we're multiplying. I'm going to say multiplying or dividing, but really dividing by 3 is the same as multiplying by a third. So essentially we just say multiplying. Yeah? Okay? And then the last one is a very famous sequence. We should all know the Fibonacci sequence. Now, this type of sequence is following a recurrence relationship, okay, where we do 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13, okay? This is some of the previous two. So, UN means what exactly? This actually means the term, okay? Whatever term we're talking about. Now, so UN, for example, if I said U3, this means the third term, okay? N means the position of the term in the sequence, okay? This is the position. For example, we have a look at the sequence here. This position is position 3. So that means n equals 3. So that means the third term, U3, equals 8. Okay, this is just some terminology. I've forgotten the word. We're rolling with that one. Okay. So, we should all be very happy with this formula. UN equals A plus N minus 1D. Okay. So this formula, when we know. Now, you may, I don't know if we have to prove the sum of sequences. Yeah, I think we do actually. We'll come to that in a minute. So if we think about this, if A is the first term and D is the difference, our first term is always going to be A, isn't it? Our second term is going to be A plus D. Our third term is going to be A plus D, because that's the second term, plus another difference, isn't it? Well, this is going to simplify to A plus 2D. Now, we're going to keep going, and our nth term, because you can see here on our first term we have no D's. On our second term we have 1D. Third term we have 2D. Our difference is always 1 less than the term we're at, aren't we? So, our nth term, which is the last term of the sequence, or any term of the sequence, is A plus 1 minus that term, 1 less than that term, multiplied by D. Now, you just have to know this formula. You do not need to know this formula. It's in the formula book, but you will probably end up memorising this formula, even though you don't need it, just because you do. So, here we go. These are 2 types of examples. The nth term of an arithmetic sequence is UN equals 55 minus 2n. So the nth term, this is saying the formula to find any term in this sequence is given by 55 minus 2n. So if I said to you, write down the first 3 terms. So the first term is U1. So what would I do? I would substitute 1 into n is now my 1, so it's 55 minus 2, which is 53. For U2 is the second term. I would substitute 2 in where n is. 55 minus 2 lots of 2, which is 4, which is 51. But you do notice, what are we doing each time? Our common ratio, our common difference each time is, we're taking away 2. So without even substituting, I could tell you the next term. Take away 2, 49. I can double check this. If my n is 3, 55 minus 2 lots of 3 is 55 minus 6. Then it says, find the first term in the sequence that is a negative. Okay, if I have a negative number, that means the number is less than 0. So technically, I want to know, when is 55 minus 2n less than 0? I don't need to sit there and put numbers in. We're mathematicians. Let's do this properly. So I'm going to get 55 is less than 2n. 55 over 2 is less than n. So that means 27.5 is less than n. So n has to be greater than 27.5. Now, did I ever once say, what is the 27th and a half term? No. Because the term, the position, are whole numbers. So really think about this. N has to be greater than 27.5, this to be negative. So what is the term, the first term where this is negative? 28. Therefore, n equals 28. Now, when in doubt, substitute in. Okay? Put in n equals 28 into here, and put in n equals 27 into here, and see which one gives you the negative. Okay? But really, we should be comfortable with this, understanding what's going on. Okay, here's a second type of example. Now, this tip is going to save you so much hassle. Now we've been given a sequence, we need to find the formula. Step 1, write down everything you know. A is our first term. What does A equal? 6. D is our difference. What does D equal? 14. The formula is UN equals A, 6, plus n minus 1 lots of 14. Okay? We can now expand this. UN equals 6 plus 14n minus 14. So UN equals 14n minus 8. And this is the formula for the nth term. Okay? Now, some of you may remember doing, how do you get from 6 to 20? 14, so it's 14n, and then 14 to 6 minus 8. You remember doing that GCSE? Very long time ago. Well, you would have done that in like year 9. Okay, you could still do that. So for the second one, our A equals 101. Our D equals negative 7. Okay, make sure we put the negative there because we are going down. Now we substitute n. UN equals 101 plus n minus 1 lots of negative 7, which equals 101 minus 7n plus 7. So therefore our UN equals 108 minus 7n. So a sequence is generated by the formula UN equals an plus b, where a and b are constants to be found, given that u3 equals 5. So you're told that u3 equals 5. You're told the formula. So that means that u3 equals 5. Using the formula, we can also say u3 equals a lots of 3 plus b. Now, I probably wouldn't write it all like this. I'm just showing you. What do they both have in common? u3. So I can then say 3a plus b equals 5. Okay? The same with ua. ua equals 20. So that means ua equals a lots of 20 by the formula they've given plus b. No, sorry. 8 plus b. So that means 8a plus b equals 20. Using simultaneous equations, you should be able to solve this and get a equals 3 and b equals negative 4. For the next one, okay, we have the first three terms of a sequence. Minus 8, x squared, and 17x. Now this one's a bit more complicated because finding the difference is a little harder. What we know about the difference though is that x squared minus this one should be the same as 17x minus this, should it not? Yeah? So, x squared minus the first term should equal the third term minus the second term. So we're going to have x squared plus 8 equals 17x minus x squared. Solving this, rearranging, I'm going to get 2x squared minus 17x plus 8 equals 0. I can then solve this to find out that x equals a half and x equals 8. I have no idea how to pronounce this name. Zin has been given a 14-day training schedule by her coach. Zin will run for A minutes on day 1, where A is a constant. She will then increase her running time by D plus 1 minutes each day, where D is a constant. Show that on day 14, Zin will run for this. Okay, because she's increasing by D plus 1, which is a constant, we know straight away this is arithmetic. The formula, day 14, is saying for a specific. So we need to use the formula UN equals A plus N minus 1D. Now what is her D? Day 1 is in fact A. Oh, sorry. So we want to find 14th day is U14, isn't it? So A equals A. Our difference equals D plus 1. And what does our N equal? 14. Step 1, write down everything you know. Okay. Here's our D plus 1. And they've said 14. Okay, now we're substituting in. So U14 equals A, which is A, plus N minus 1, 14 minus 1, multiplied by D, which is D, plus 1. I'm going to expand and simplify. A plus 13D plus 13. Therefore, proved or shown, I don't mind. Okay. Then says, Yi has also been given a 14-day training schedule by her coach. Yi will run for A minus 13 minutes on day 1. She will then increase her running time by 2D minus 1 minutes each day. Given that Yi and Xing will run for the same length on time on day 14, find the value of D. Okay, so first of all, again, I'm going to write down what I know. For Yi, our A is A minus 13. Our D is 2D plus 1, and our N is still 14. So we can create the same formula. So U14 equals A minus 13 plus 14 minus 1, lots of 2D plus 1. Yep, sorry everyone, slight error. There should be negative 1. Oops, make sure you read the question properly. 2D minus 1. So we're going to get A minus 13 plus 26D minus 13. So I'm going to get A minus 20 plus 26D minus 26. Now this is what U14 equals. So now I'm going to have a pair of simultaneous equations. So I'm going to have A plus 26D minus 26 equals A plus 13D plus 13. Now I can already see that I can cancel A from both sides. Minus 13D from both sides leaves me with 13D. Add 26 to both sides equals 39. Therefore, D equals 3. Now, again, this is something we would have seen in the IGCSE. The sum of the first n terms is given to us by the formula Sn equals a half lots of n bracket 2a plus n minus 1d, and we'll look at proving that later on in the chapter. Now, an alternative formula they give you is Sn equals n over 2a plus l. They give you both of these formulas in the formula booklet. Sometimes we would need one or the other, because sometimes they do not tell us the difference, they just tell us the last term. Okay, so depending on what the question gives you. Okay, so here are a few examples. Step 1, you always write your a, d and n. For question 1, 2, 5, 8, 11, 14. So for question 1, our a is our first, which is 2. Our difference is 3, and our n, it wants the sum of the first 30 terms. Now, because we've been given our first term, our difference, and our n, the formula we're going to use is going to be a half. Sorry, I always write n over 2, lots of 2a plus n minus 1d. Remember, this is what Sn equals, or Sn equals a half n over 2, a plus l. Okay? So, for the first one, I'm literally going to substitute this in. I'm going to have 30 over 2 lots of 2 plus 30 minus 1 multiplied by 3. I'm going to put that into the calculator, and it's going to give me S30 equals 1365. I can do the same for the second one, just making sure that my A is 100, my difference is minus 2, and again my N equals 30. Substituting, I'm going to get 2130. And then for the third one, it's the same again. My A equals P. My difference, well, you can see 3p minus 2p is p, and 2p minus p is p. So my difference is p, and my n equals 30. I'm going to substitute that in, and I'm going to get 465p. Okay, now this is a type of question that we have seen in the GCSE. Find the minimum number of terms for the sum to exceed 2,000. Step 1, write down what you know. A equals 4. Our difference equals 5. Our n, unknown. But what do we want? We want our sum to exceed. We want this to be greater than 2,000. Now I substitute all this into the formula. So I'm going to put 2,000. Our formula needs to be greater than 2,000, doesn't it? Yeah? So 2,000 has to be less than n, because we don't know it, over 2 lots of 4 plus n minus 1 lots of 5. So I'm just going to multiply everything by 2 first. 4,000 has to be less than n lots of 8 plus 5n minus 5. 4,000 has to be less than. Now, 8 minus 5 is 3, so I'm going to have 3n plus 5n squared. Now you're going to see I'm going to have a quadratic, so I'm going to write this again. 5n squared plus 3n minus 4,000 has to be greater than 0. I'm going to put that into my calculator, okay? And this is going to give me, remember, if it's greater than 0, if we go back to when we used to do our discriminants, if it's greater than 0 on the graph, and it's a positive quadratic, we are looking for 2 inequalities now. This side and this side, aren't we? So this is where we're bringing all the skills together. When I solve this, I'm going to have n is less than minus 28.5, or n is greater than 27.9. First of all, I'm rejecting the negative, because we do not have a negative term. Okay, you either have the first term, but you wouldn't have what's the negative fifth term. That's not how a sequence works. When we have a sequence, we start from the first term. So we reject the negative. It then says n has to be greater than 27.9. So what is the next whole number? 28. So n has to be 28. This is the minimum number of terms to find the sum of 2,000. Now again, if you're not sure, put in 28, 27, but really we should be thinking logically about what's being asked here. So, a company offers 2 salary schemes for a 10-year period, year 1 to year 10 inclusive. Scheme 1, salary in year 1 is P. So straight away this tells me that A equals P. The salary increases by 2t each year, forming an arithmetic sequence. Arithmetic means we have a difference, and our difference is 2t. Scheme 2, the salary in year 1 is P plus 1,800. So that means my A equals P plus 1,800. And each year it increases by t. So my difference is t. Show that the total earned under salary scheme 1 for the 10-year period. So that means the total is the sum. So that means the total year 1 to year 10 inclusive means n equals 10. We want the sum of the first 10 terms. Okay? Now, a key point to note here, if it says the total, we are looking for the sum. So we know that S10 equals n over 2 multiplied by 2 lots of A plus n minus 1 lots of D. Okay, now again, you do not need to remember this formula. This formula gets given to you. Please work this out. So this is actually going to give me, so S10 equals 5 lots of 2p plus, and then 10 minus 1 is 9, times 2, 18t. If I multiply this by 5, I get 10p plus 90t, therefore shown. It now says, find the 10-year, for the 10-year period, the total earn is the same for both salary schemes. We know scheme 1 is 10p plus 9t for 10 years, so we need to find the sum of 10 years for the second scheme, and then we will have a simultaneous equation, and then we can find it out. So, S10 for the second scheme, I'm going to do in a different colour. Remember, our n is still 10 over 2. Lots of 2 lots of A. Our A in this case is P plus 1,800 plus 10 minus 1 lots of T. Now, when I expand and simplify this, I get, so this equals, S10 equals 10p plus 1,800 plus 45t. Now I can put these equal to each other because we know that the sums are the same. So therefore that means I have 10p plus 90t equals 10p plus, is that 180 or 1,800? 1,800 plus 45t. There should be a 0 here. Now the 10p's are going to cancel. That means 45t equals 1,800. 1,800 divided by 45 is 400. So therefore t equals 400 is the final answer.
Okay, wait, so this is 1,800 times 2 times 5.
18,000. Okay, sorry, mix up in the class with the amount of zeros going on. The next one says, for this value of t, the salary in year 10, under scheme 2 is 29,850. Find the value of P. So because it says in year 10, we're looking at the 10th term. Now U10 equals A. Now remember we're on scheme 2. Our A is P plus 1,800 plus N minus 1, 10 minus 1 lots of D, which is T. So we know that U10 is 29,850. This equals P plus 1,800 plus 9 lots of T, and we've just worked out that T is 400. When I multiply, simplify, and rearrange, my P equals 24,450, and my units is pound. So that's the final answer in pounds, 24,450. Okay, so we've just had a recap of arithmetic sequences and the style of questions that you're going to get. Okay, now we're going to look at geometric sequences. Now we know geometric sequences have a common ratio. So what we're going to do is we're going to have a quick look at the common ratio. So are we ready? What's the common ratio of number 1? 2. Common ratio of number 3? 27 times 3 is not 18. 2/3. 27 times 2 over 3, does that give me 18? Yes. 18 times 2 over 3, does that give me 12? Yes, that's how I know. Okay, how about the next one?
Number 2.
A half, well done. The next one? Minus 1, brilliant. The next one? Minus 2x, fantastic. The next one? P. And the next one? Negative a quarter, absolutely. Now remember, we're not looking at dividing, we're looking at multiplying. Remember, dividing by 4 is the same as multiplying by a quarter, okay? This is what we're looking at. So here we have identified the common ratios. Now, just like we saw earlier, it's really important. So, how do we do this? Actually, you know earlier when we had a missing, we had to find out the difference. To find the common ratio, we would do term 2 divided by term 1. Yeah? Or term 3 divided by term 2. We would pick a term and divide it by the previous term. This is a fun fact that you need to know. Okay, so we have an arithmetic sequence. To find the nth term, what formula we would use, and I've told you they give you this in the formula sheet. This is A plus n minus 1d. And then for a geometric series, the nth term is given to you by A multiplied by R to the power of n minus 1. Okay, and again, we'll be able to see that. Now, first of all, we look at the sequence, okay, because sometimes it doesn't tell us if it's geometric or arithmetic. So step 1, we look at the sequence. How do we get from 3 to 6? We could add 3, couldn't we? Or we could times by 2. So then we look at the next, 6 to 12. Okay, it's clear that they've multiplied by 2. This is a geometric series. With geometric, we need the common ratio. So we write down A equals 3. A is always our first term. R equals our common ratio, which is 2. And N equals, we want the 10th term. In this case, then our N is 10. And to write this, we know that U10 equals 3 lots of 2 to the power of 10 minus 1, which is going to give me 3 times 2 to the power of 9. I'm going to work that out. and I'm going to get 1,536. Okay? Now, if I want to find the nth term, I would do the exact same, apart from this is just giving me a formula of un equals 3 times 2 to the power of n minus 1. Now, instead of writing 3 times, you can just do 3 bracket 2 lots of n to the power of minus 1. Okay? Can you do this for the second one, please? Okay, then, so for this one, my starting term is 40. Now, it's not really clear to me what my ratio is right now, but what I do know, to find my common ratio, I can pick a term and divide it by the term before. So, minus 20 divided by 40 is negative a half. And then my n is 10. So, for u10, I'm going to have a, which is 40, multiplied by r, which is negative a half to the power of 10 minus 1. This means that u10, when I substitute this into my calculator, is going to give me minus 5 over 64. Now, that means that my un equals 40 lots of negative a half to the power of n minus 1. Okay? Okay, so now we know this rule. The rule that we've been using is un equals a to the power of n minus 1. This is a typical question. They don't normally give you a sequence and ask you to write the formula. They will give you a bit more problem solving. Off you go. Okay, so the second term of a geometric sequence is 4. So, you can do 2 things here. When in doubt, draw it out. Okay? 1, 2, 3, 4, 5, 6. It says the second term is 4. This is u2. So this means u2 equals 4. Okay? Now, I prefer you to write u2 equals 4, but I'm happy if you... Oh! And the fourth term, 1, 2, 3, 4, is 8. So this is u4 is 8. Find the common ratio. So, hold on a minute. How did I get from this term to this term? I multiplied by r. And then what did I do? From here to here, I multiplied by r. So that means 4 multiplied by r equals 8. This is the same as saying 4 times r squared equals 8. So r squared equals 8 over 4, which we know is 2. So r equals root 2. So now, it wants the first term. Just a note, sorry, this could be plus or minus root 2, but it says the common ratio is positive. Please read the question. Okay, for the second one, it says, so this is A. For part B, it says find the first term. So I can literally just divide by r. 4 divided by root 2, which equals 2 root 2 when I rationalise the denominator. Then for part C, it says find the 10th term. So u10 equals A, which is 2 root 2, multiplied by r, which is root 2, to the power of 10 minus 1, which is 9, which is going to equal 64. Okay, here we go, off you go. So the numbers 3, x and x plus 6 from the first 3 terms of a positive geometric sequence. Find the value of x. So you know the first 3 terms are 3x and x plus 6. Now again, you know to find the common ratio, as I said, you could do term 2 divided by term 1. X over 3 equals R. What else will enable us to get our R? Well, the third term divided by the second term also gives us R. So that actually means that I can say X over 3 equals X plus 6 over X because they both equal our common ratio R. That means if I multiply both sides, X squared equals 3 lots of X plus 6. X squared minus 3X minus minus 18 equals 0. If I now solve this, two numbers that multiply to give me 18. 6, so minus 6 plus 3. So X equals negative 3 and X equals positive 6. Now it says that the geometric sequence is positive, so we're going to reject negative 3. Okay, reject. So that means if I was to rewrite this sequence and substitute in, 3 is my first term. X is my second term, which is 6. X plus 6 is my second term, so 6 plus 6, which is 12. You can now see our common ratio is 2. So once we found the value of X, which is 6, I've then found my common ratio. So I write down what I know. A equals 3. A is always the first term. R is our common ratio, which equals 2. If they want the 10th term, that means our N equals 10. So U10 equals A multiplied by R to the power of N minus 1. Now, when I put this into my calculator, I then get 1,536. Here's another type of question. Off you go. Okay, what is the first term in the geometric progression? Now, it says term. So that means UN. The first term, which is greater than a million. Okay, so step 1. What do we need to know? What's our A? 3. What's our ratio? 2. So the formula is, we want 1,000 to be less than, okay, 3 times 2 to the power of n minus 1. Okay, step 1, divide by 3. So we're going to have 1,000,000. Oops. Divided by 3 has to be less than 2 to the power of n minus 1. Okay. How do I find this? Log both sides. Okay? So log of 1,000 divided by 3 is less than log of 2 to the power of n minus 1. Now using log laws, log A to the power of B can be written as B log A. So log of 1,000,000 over 3 is less than n minus 1 log 2. Now I'm going to divide both sides by log 2. Log of 1,000,000 over 3 divided by log of 2 is less than n minus 1, and then I'm going to add 1 to both sides, okay? But before I add 1, I'm going to put this into my calculator and actually figure this out. So n minus 1 is greater than this. I put this into my calculator, I get 18.35. So that means n is greater than 19.35. The next whole number is 20. So that means n equals 20. When n equals 20, the term would exceed 1,000,000. All the terms that are geometric sequence are positive, okay, and we have a geometric sequence. It says that the third term of the sequence, so we know that un equals AR to the power of n minus 1. So for the first one, it says the third term is 20. So we know that U3 equals 20. So that means that 20 equals a to the power of r squared. Because this is 3 minus 1, but that equals 2. Then we know that the fifth term is 80, so U5 is 80. So our n is 5. So 80 equals AR to the power of 4. Now, I have simultaneous equations here. So what I'm going to do is I can divide, I can rearrange. So if I wanted to, I could say 20 over a equals r squared. And then we're going to have, substitute in the second one, 80 equals 80 equals a lots of 20 over a squared. So this is going to be 80 equals 400a over a squared, which becomes over a. So 88 equals 400. So a equals 400 divided by 80, a equals 5. And then if I substitute that back in, you can get 20 equals 5 lots of r squared. So 4 equals r squared. So r could be plus or minus 2, but it does say that the sequence is positive, so all of the terms are going to be positive. So we found a, we found r, and it says what's the 20th term? So u20 equals a, which is 5, multiplied by r, which is 2, to the power of 20 minus 1, which we know is 19. This is going to give me 2,621,440. 2,621,440. Okay, the second, third and fourth term of a geometric sequence are the following. Okay, so we do have one here, which is a. Then it says determine the possible values of x. So we know that x times our ratio equals x plus 6. And we also know that x plus 6 multiplied by our ratio equals 5x minus 6. So here we can say our ratio is x plus 6 over x. And then for this term we can say our ratio is 5x minus 6 over x plus 6. What we can now do is put these equal to each other. X plus 6 over x equals 5x minus 6 over x plus 6. I'm going to multiply both sides and expand, and I'm going to do this rather quickly. So we're going to have x squared plus 12x plus 36 equals 5x squared minus 6x. I'm going to move everything to the right-hand side. 4x squared minus 18x minus 36 equals 0. And then I'm going to solve this. You can either solve this by factorising or substituting into a formula. And then what I'm going to have is x equals 6 or x equals a negative 3 over 2. And this is, we've now found the possible values of x. Part B says, given the common ratio is positive, find the common ratio. So for part B, we know that ratio equals x plus 6 over 6. So 6 plus 6 over 6 is 2. So my ratio equals 2. And then part C, says, hence determine the possible values of the first term of the sequence. So we know that x equals 6 and our ratio equals 2. So we know that our sequence goes A, 6, 12, 5 times 6 is 30 minus 6 is 24. And then we know our ratio is 2. So 6 divided by 2 is 3. So that means A equals 3. Okay, we know the sum of an arithmetic sequence is n over 2 lots of 2a plus n minus 1d. Now, as I said, you do not have to memorize this. This is in the formula book, but what you'll find is that you do memorize it. The sum of a geometric series is a lots of 1 minus r to the power of n all over 1 minus r. Okay, and we're going to have a look at the proof of this a little later. A type of question that you need to know the skills for. So find the sum of the first 10 terms. Now, as I keep saying over and over again, it's really important that we write down everything. A is our first term, which is 3. R is the ratio. 3 multiplied by what is 6? In this case, it's nice and easy, it's 2. And n is the number of terms we want, and we want the sum of the first 10 terms, so our n is 10. I'm now literally going to substitute this in. 3 lots of 1 minus 2 to the power of 10 all over 1 minus 2. This is going to give me a total of 3,069. I'm going to do the same for the second one. My A is 4. My R is a half. So I'm multiplying by a half each time, and my n is the first 10 terms. So I'm going to have 4 lots of 1 minus a half to the power of 10 divided by 1 minus a half. And this is going to give me 1,023 over 128. So this skill is nice and simple. It's really easy to find the sum of the first however many terms using this formula. Find the least value of n such that the sum of 1 plus 2 plus 4 plus 8 to n terms would exceed 2 million. Okay, so we're trying to find the smallest value of n for such that the sum of this would exceed 2 million. So we want Sn to be greater than 2 million. Okay? Now, it hasn't told us the sequence is geometric. We know it is because that's what we're doing right now, but we double check. So 1 to 2 multiplied by 2, 2 to 4 multiplied by 2. So we know this is geometric. So I'm going to write r equals 2, a equals 1, and our n we're not sure yet. Okay? So I know the sum Sn equals a bracket 1 minus r to the power of n all over 1 minus r. So I want my sum to be greater than 2 million. So I want 2 million. I want my formula to be greater than 2 million. My a is 1. 1 minus 2 to the power of n over 1 minus 2. So now what I'm going to do is I'm going to rearrange 1 minus 2 minus 1. Now if I multiply this by negative 1, what's going to happen? I'm going to flip the sign, okay? So I'm going to have negative 2 million is greater than 1 minus 2 to the power of n. Okay? Now I'm going to take away 1 from both sides. So minus 2 million and 1 is greater than negative 2 to the power of n. I'm actually going to divide both sides by negative 1 again. And I'm going to write the 2n on the left-hand side. So 2n is greater than 2 million and 1. How do I find what n is? Using logs. Now remember the log law. A to the power of b equals c. This now means that b equals log to the base a of c. So n is greater than log to the base 2 of 2 million and 1. I'm going to put that into the calculator and it's going to give me 20.9. So the smallest possible value is when n equals 21. Okay, test your understanding. 8 marks, 8 minutes. The second and third terms of a geometric series are 192 and 144 respectively. So I really like to write this down. So the first one we're not sure yet. Second is 192, third is 144. For this series, find the common ratio. Now I know the common ratio is found because 192 multiplied by r is going to give me 144. So I could even write that down if I wanted to. And then I know to find r, I'm going to have to do 144 divided by 192, which is going to give me 0.75. It then says find the first term. Now I know to get from the first to the second term I have to multiply by r, so it stands to reason to get from the second term to the first term I need to divide by r. So 192 divided by 0.75 is going to give me 256. So now I know my first term is 256. So my a equals 256 and my r equals 0.75. It says the smallest value of n for which the sum of the first n terms of the series exceeds 1,000. So we want Sn to be greater than 1,000. So that means 1,000 has to be less than a to the 1 minus r to the n over 1 minus r. So we're going to have 1,000 is less than 256 multiplied by 1 minus r to the power of n, 1 minus 0.75 to the power of n, all over 1 minus 0.75. Now 1 minus 0.75 is 0.25 multiplied by 1,000 is 250. Okay? 250 is less than 256, lots of 1 minus 0.75n. I'm going to divide by 256. 1 minus 0.75 to the power of n. I'm going to take away 1. 250 minus 1 is negative 6 over 250. Is less than negative 0.75 to the power of n. If I divide both sides by negative 1, I'm going to get 0.75 to the power of n is less than 6 over 256. Oh, sorry. Now I'm going to use my log laws. So n equals log. N is less than log to the base 0.75 of 6 over 256. This is going to give me, yes, it is greater than.
6256 divided by 0.77.
Okay, this is greater than, so I'm going to get n is greater than 13.0471, so n equals 14. Okay, but I have made a mistake somewhere. Find the smallest value of n for which the sum of the first n terms exceeds.
That's right.
So when is this greater than 1,000? So it's greater. We multiplied by 0.25, that didn't change the sign. We then minused 1, that shouldn't change the sign. It doesn't. I then divided everything by -1. This should change the sign. So how has it now changed to greater than here? Oh. Yeah, I did change it. I put it on this side. Okay, we'll come back to this. Okay, yeah. One of those Sunday morning feels. Okay, I'm not sure what's going on here. But, yeah, when in doubt, okay, try it out. Put in 13, put in 14, see which one makes sense. Okay, so the big reveal. Basically, so everything we've done so far is mathematically correct, okay? So from here, this is 0.75n is less than 6 over 256 is completely correct. Why does the sign then change when we go here? Because when we apply the log to both sides, because the base is less than 1, we change the sign. Because if you were to draw the log graph, you would find that when it's negative on the y-axis when the log graph is less than 1, because it crosses the positive x-axis at 1. So when the base of the log is less than 1, this is when we would change the sign here. This is a very common mistake that people do, is not changing the sign. But again, as I've always said, when in doubt, put the numbers in and figure it out. So divergent versus convergent, okay? So divergent is a series which, for example, this one, if I kept adding these, what's going to happen? This is going to give me, it's just going to go up to infinity, okay? So this is divergent. For the next one, I'm going to go 1 minus 2 is going to give me -1. Plus 3 is going to give me 2. Minus 4 is going to give me -2. So this is divergent because it's going to keep going either side of 0. Okay? But gradually it gets away from 0. So it's going to start off like this. And then gradually it gets away. So we can see we're up, down, okay? So it's divergent. For the next one, 1 plus a half plus 0.25 plus 0.125. Each time we're halving the term, okay, and then add it on. Now this is actually convergent. Because what's going to happen is, if we start at 1, okay, so this is 1. If I add 1, I'm going to go here. Then if I add a half, here. Then a little bit more, then a little bit more. And then what we're going to find is we're actually going to have an asymptote at the line y equals 2. It's going to converge no matter, because if we keep halving each and every single one, you're going to find that it's going to keep going, and it's going to converge. Okay, because it's going to want to try and meet 2, but it's never going to. So if you put 1 in your calculator, add 0.5 is 1.5, plus 0.25, we're now at 1.75, plus 0.1258, we're now at 1.835. Am I lost? Anyway. And then if we add on half of 0.125, we're never actually going to reach 2. This is called convergent, okay? It's really, really important that we understand the difference between divergent and convergent. I'm also going to give a bag of Haribos to anyone who can tell me what these are, and we'll come back to these later. So, we're going to have a look. Sometimes, to know if we can have a series where we have a convergent, but it would be nice to know, well, what will this converge to? How did I know that that converged to 2? Well, if we keep going, we notice that our ratio here, 1 to 0.5, our ratio is 1/2. And here, 1 to 2, our ratio is 2. So, the rule is an infinite series will converge provided that the ratio is in between -1 and 1. Now what you can see here is it says the modulus. This means the modulus of r is less than 1. And it means we take the positive. It doesn't matter what r is, positive or negative, we take the positive of it, okay? This is the same as saying -1 is less than r is less than 1. Now, provided that the modulus of r is less than 1, what happens to r to the power of n as n tends to infinity is that as n tends to infinity, r to the power of n tends to 0, okay? So, we now have this new formula in the formula book. Okay, so very quickly, we know the formula is the sum to infinity equals a over 1 minus r. So for this one, what is my a? 1. What is my r? 1/2. My sum to infinity is 2. For the second one, my a, 27. What is my r? -1/3. My sum to infinity is 27 over 1 minus -1/3, which is going to give me 81 over 4. So if you were to keep going forever and add these up, this is what it's going to eventually try to converge to. Get as close to this number as possible. For the next one, a is p. My r is p. So I'm going to get p over 1 minus p. For the next one, we have p. My ratio is 1 over p. So we're going to have p over 1 minus 1 over p. Now, we're not allowed to leave it like this, and you can see here that p is our denominator. We have another, like a fraction within a fraction. I can multiply everything by p every term, so I'm going to get p squared over p minus 1. This is the exact same. They are completely equivalent. The fourth term of a geometric series. Now, straight away, I'm going to go to the formula book, and I know that the fourth term, so that means that U4 equals, and I know geometric is A, this is 1.08. And I know in a geometric series that UN equals A to the power of Rn minus 1. So 1.08 equals A to the power of R cubed. I'm going to do the same to find U7. It then says the seventh term. Okay, so we know that U7 is going to equal 0.23328. So that means 0.23328 equals a to the power of r lots of 7 minus 1, which is 6. Okay, now we have simultaneous equations. Okay? So you can rearrange and then substitute or divide them. But what you'll then find is r cubed equals 0.23328 divided by 1.08, which is 0.216. So if we cube root that, we're going to have r equals 0.6. It now says find the sum to infinity of this series. Now, to find the sum to infinity, we need to know if it converges. It converges if the modulus of r is less than 1. Okay, now remember what we said about this modulus means we take the positive value of whatever r is. If this is less than 1, okay, remember, so r's got to be in between -1 and 1. r is 0.6. 0.6 is less than 1, therefore converges. If it converges, we can use the sum to infinity. The sum to infinity equals a, which we don't know. We've got to figure out a. Okay, over 1 minus r, which we know is 0.6. Okay, how do I find a? Well, here I could rearrange this, do 1.08 divided by r cubed. This is actually going to give us 5. Then the sum to infinity is then going to equal 12.5. For a geometric series with first term a and common ratio r, S4. Now this clearly tells us that the sum is 4. Now we know the formula for the sum is given to us in the formula book. Sn equals a lots of 1 minus r to the n over 1 minus r. You do not need to learn these because these are given to you. So, when it says S4 is 15, S4 equals 15, that's the same as writing 15 equals a lots of 1 minus r to the power of 4 over 1 minus r. It says the sum to infinity equals 16. So the sum to infinity equals a over 1 minus r. This equals 16. We now have simultaneous equations. We know that a okay, this is how I would substitute it in. Now, being able to spot this as a mathematician will make your life easier. 15 equals a over 1 minus r times 1 minus r to the power of 4, does it not? Absolutely. So actually, I could then say, I know that a over 1 minus r is 16, so 15 equals 16 lots of 1 minus r to the power of 4. This is how I would use substitution. Instead of rearranging, trying to find a, you can substitute any which way you want, as long as it's exactly the same. We cannot change the value. So I'm going to get 15 over 16. Okay. So 15 over 16 equals 1 minus r to the power of 4. If I take away 1, negative 1 over 16 equals negative r to the 4. So that means 1 over 16 equals r to the power of 4. So r equals, now it's really, really important that we know when we have a power to an even number, we're going to have two solutions. It's going to be plus or minus a half. Okay? Now, you have to write that to get the full marks. Part B says, given that all the terms in this series are positive, because it tells us that all the terms are positive, we now know that r equals a half must be the actual answer. But for the one before, if you didn't put plus or minus, you will lose a mark. Okay? And it tells us find the value of A. Well, we know that 16 multiplied by 1 minus R is going to give me A. So 16 multiplied by a half is going to give me A. So my A is 8. Okay, and I've just substituted that in to this formula here. The second and third term of a geometric series are 192 and 144 respectively. For this series, find the common ratio. So we know the second, so if we have first, second, third, we know this is 192, this is 144. How do we get from the first to the second? We multiply by R. How do we get from the second to the third? We multiply by R. How do I know this is true? It clearly says this is geometric, and we know with geometric we're multiplying by a ratio. So to find the ratio, I'm going to do 144 divided by 192. Now when I put that into my calculator, this simplifies to 3 over 4. It then says find the first term. So something times 3 over 4 is 192. So 192 divided by 3 over 4 is going to give me 256. It then says find to the sum to infinity. Now I know I can do that because the modulus of R is less than 1. 3 over 4 is less than 1. So this means it is convergent. Now we know that this is A, which is 256, over 1 minus R, which is 1 minus 3 over 4. This is going to give me 1024. Part D says the smallest value of n for which the sum of the first n terms of the series exceeds 1000. So I want to know when S10 is greater than 1000. Okay, what is S10? This is A lots of 1 minus R to the 10 over 1 minus R. This has to be greater than 1000. I know my A is 256. To 256 lots of 1 minus 3/4. Sorry everyone. I don't know why I've put 10. It's supposed to be n. I think it's because I had 10,000 in my head. Okay, to the power of n over 1 minus 3/4 is greater than 1000. Now, if I have 256, 1 minus 3/4 to the power of n is then greater than, if I multiply that by a quarter, I get 250. I then get 1 minus 3/4 to the power of n is greater than 250 divided by 256. I'm then going to take away 1 from both sides. So minus 3/4 to the power of n is greater than 1. What's 256 minus 1? Negative 6 over 256. Okay. Now I'm going to log. Now, we don't really like logging negative, so I'm going to multiply everything through. So I'm going to get 3 over 4 to the power of n is less than 6 over 256. Now I'm going to have log 3 over 4 of 6 over 256 is less than n. So that means n is going to be 13 point something, so n is 14. Okay? Nice and simple, 10-mark question. So, sigma notation. This is the Greek letter, and it's capital sigma, and it means the sum. Okay, we would have seen this in stats. You know, when we have the sum of x. Okay? So, the numbers on the top and bottom tells us what R varies between. So, in this case, R does not mean ratio, okay? So, you know, with geometric, we have the R, and this is our ratio. This is not what's happening here. For example, and this is the expression, our R is technically our N. So this is saying this goes from the first term to the fifth term. So when R equals 1, I substitute it in here. My first term is 3. When R equals 2, I substitute it in here and I get 5. And then you can see that this is an arithmetic series. And this is basically, this is saying I want the sum of the first 5 terms of this arithmetic series. So, here's an example. So, first of all, what we do is we determine what's going on. So here it says n equals 1. It means we start with 1. We substitute in 1 and we get 3. When we substitute in 2, 6. When we substitute in 3, 9. When we substitute in 4, 12. And you can see here it goes up to 7. So 1, 2, 3, 4, 5, 6, 7. This is the whole sequence. This is what the summation sign essentially tells us. Before, we were going up to the sum to, you know, find out how many could exceed 1,000. This will not exceed 1,000. So now, we need to figure out, is this geometric or is it arithmetic? Now we can clearly see this is arithmetic. Our first value is 3. And our difference is 3. And our n. How many terms in this sequence? 7. Okay? So then, the final result is, we know that S, the sum of the first 7, we know is A, so which is n over 2, lots of 2A, plus n minus 1, lots of D. Okay, and when I figure this out, I get 84. Okay, so we're going to do the same again. Now, we start when k equals 5 is going to be our first term, and then we go up to 15. Now, do you remember in stats, some of us had trouble counting? Okay. Between 5 and 15, how many numbers is that? We're going to count. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Between 5 and 15 is 11 numbers, inclusive of 5 and 15. Okay? Watch out for that. A lot of people get this wrong. So anyway, when I so we skipped ahead here, but that means our n equals 11. Okay, so when we enter k equals 5, 10 minus 2 lots of 5, 0. When k equals 6, 10 minus 2 lots of 6, negative 2. 10 minus 2 lots of 7, negative 4, etc. Now it's clear that this is arithmetic, sorry, it's not geometric. And you can clearly see here that when we're multiplying and add and take away, this is going to be arithmetic. We're going to see here that this is going to be geometric, so it's to the power of. Okay? So our A is 0. Our difference, negative 2. So now when we're going to find the sum, I'm going to substitute the sum of the first 11, which is 11 over 2, multiplied by 2 lots of 0, plus 11 minus 1 lots of our difference. And it's going to give me the sum of the first 11 terms, which is minus 110. Okay, for the next one, k equals 1. If I substitute this in, 5 times 3 lots of 0, 5. K equals 2. 5 times 3, 15. K equals 3. 5 times 3 squared. 5 times 9? 45. Okay. Our A is 5. Do we have a difference? No, because this is geometric. Ratio is 3. We're multiplying by 3 each time. Okay. Now, what else do we know? Our N. How many numbers are there, including 1 and 12, between 1 and 12? 12? Absolutely. So we know the formula is S12 equals A, lots of 1 minus R to the power of N over 1 minus R, which is going to give 1, 3, 2, 8, 6, 0, 0. Now, we can actually use a calculator for this, okay, to figure it out. So, with the next one, here we want to start when K equals 5, okay? So you can use the same method, or you could do this. The sum of 12 when K equals 1 of 5 times 3 K to the minus 1, take away the sum. Now remember, if we want 5 upwards, 4 is 1 less. 5 times 3K to the minus 1. So we could either figure it out using how we've been doing, or we know that the sum of the first 12 minus the sum of the first 4 is going to give me the sum from number 5 to 12. Okay? Okay, so here we have a typical question. Now you can do the direct method where we know, for example, that the sum when R equals 10 to 30 of 7 plus 2R. So we start when R equals 10. So we're going to have 2 times 10 is 20 plus 7 is 27. 11 times 2 is 22 plus 7 is 29. And then the next one's going to be 31. Okay, so we can see here, this is the start of our sequence. So our first term is, value is 27. Our difference is 2. And our N is how many? Now remember, even though the difference from 30 to 10 is 20, we're including 10 and 30, so it's 21. I can now find the sum of the first 21st terms, which is N over 2, lots of 2A, plus N minus 1, multiplied by D. I put this into the calculator, I'm going to get 987. Then what we could do is the subtraction method, where when we have the sum, when R starts at 10 to 30, of 7 plus 2R. This is the same as finding the sum when R equals 1 to 30 of 7 plus 2R, and taking away, it's when R equals 1, and this time, because we want it to be 10 is the next one, to 9, 7 plus 2R. Okay, and then you're able to work that out, and you should get the exact same answer. Please check this and decide which method you prefer. Okay, so you can use this on your calculator. Please have a look at it. I'm not sure how to do this yet. I'm sure there's YouTube videos on this, so have a look. Then can you complete the questions from the textbook, please? I suggest you look at questions 10, 11, 12. Okay, so we're moving on now to recurrence relations, and this is an example of a position to term sequence. So each term is based on the position, okay? And then here, what we have is this term is based on the term before. So this is known as a term-to-term sequence or a recurrence relation. As a sequence, it keeps referring to itself, so it's based on the previous answer. Here's an example. So a sequence x1, x2, x3 is defined by when x1 equals 1, xn plus 1 equals xn squared minus kxn. So what I would do immediately is I would put 1 into my calculator and then press equals, and then you're going to get 1. And then what I would put into my calculator is bracket answer squared minus k lots of my answer. Because I'm going to substitute in my answer as k. Then this is going to give me my next one. So I'm going to get 1 squared minus k lots of 1. Okay? Which we know is 1 minus k. This is what the second term is. And it says show that x3 equals this. So now I'm going to substitute this into my x2 ready for x3. So I'm going to have 1 minus k squared minus k lots of 1 minus k. And all we're doing is substituting in here the answer from the previous one. So this is what x3 equals. So I'm going to get k squared minus 2k plus 1 minus k plus k squared. This is going to give me 2k squared minus 3k plus 1. Therefore, proved. So it's given that the third term, x3, is 1. Calculate the value of k. So we know that 2k squared minus 3k plus 1 equals 1. So that's the same as 2k squared minus 3k equals 0. I can factorise out a k. So we're going to get 2k minus 3 equals 0. So k equals 0, or k equals 3 over 2. Now, k cannot equal 0 because it says in the question it is a constant. So we're going to reject. And our final answer is 3 over 2. Then it says, hence find the value of the sum when n is 1 to 100. So what we're actually going to do here is when these types of questions come up, there's most likely some kind of repeating sequence. So I'm going to put this into my calculator, what I said I'm going to do. I'm going to put 1 equals and then answer minus 1 minus k. And this is what's going to happen. My first answer is 1. Then when I put 1 into my calculator, I get minus a half. Then when I put minus half into my calculator, press equals, I get 1. And then I get minus a half. So you can clearly see that there is a pattern. What does this mean? What is 1 minus a half? The answer is a half. And how many times? From 1 to 100, what do we have here? This is 100 terms. So I'm going to have 50 lots of this pattern. So it's 50 times a half, which is 25. Okay, I'd like you to test your understanding with this question, and I will go through it in a second. Question 4. A sequence x1, x2, x3 is defined by x1 equals 1 and xn plus a plus xn plus 5. And n is greater than or equal to 1, where a is a constant. Write down the expression for x2. So we're going to substitute in what x1 is. So we're going to have a lots of 1 plus 5, which is a plus 5. It then says that show that x3 is this. So I'm now going to substitute my x2 into this original equation to find what x3 is, because this is how I find x3. x3 is found by doing a lots of x2 plus 5. So a lots of a plus 5 is equal to a squared plus 5a plus 5. Therefore, proved. And it says that given that x equals 41, find the possible values of a. So x squared plus 5a plus 5 equals 41. A squared plus 5a minus 36 equals 0. I can factorise this, 9 and minus 4. So a equals minus 9 and a equals 4. Now, it doesn't say that a is positive or negative, so we can accept both. Okay, if you're happy with this, please can you do the questions in the book? And the last part is knowing if a sequence is increasing, decreasing, or periodic. So a sequence is strictly increasing if the terms are always increasing, okay? And it's strictly decreasing if the terms are always decreasing, you know, so if it's going 1, 2, 4, 8, 16, it's strictly increasing, and strictly decreasing would be, you know, 10, 5, 2.5, etc. So, and a sequence is periodic if the terms repeat in a cycle, okay? And a periodic sequence as well, don't forget the sine graphs, they're periodic. Now, for each sequence, we're going to state if it's increasing, decreasing, or periodic, and if so, why. We have to write down the order, okay? Now, what we do to do this is we substitute in these values, okay? So when u1 is 7, I'm going to have 7 plus 3. Oh, u1 is 7. Okay, so 7 is the first one. 7 plus 3, 10. 10 plus 3, 13. Okay, this is strictly increasing. For the next one, we start with a half. A half squared, a quarter squared, a 16th. Okay, you can clearly see this is getting smaller each time. So, what is going to happen? This is strictly decreasing. Okay, so this sequence saying what happens every 90. If you think about the sine graph, at 0, it's 0. On the first 90, it's 1. The second lot of 90, we get to 180, 0. The third lot of 90, negative 1. After 90 more, we're back at 0. Oh, sorry, everyone. We should have started at 90, not at 0, because it says 90n. And then the next lot of 90, we're going to be back at 1. Okay? So this is saying that every 90, this is then going to continue 0. So this is, in fact, periodic order. Oh, my spelling's gone awful then. Periodic order 4, because it repeats every 4. Okay, have a look at some of these questions. Well done. That we have now finished sequences.